Okay, in today's video, we're going to go over a fire alarm design example. So we'll first discuss the relevant fire alarm code sections for a business/factory occupancy type building. So in this example, it's going to be a mixed use type building where, some portions of the building is going to be a business occupancy and other portions will be for a factory occupancy. Then we'll discuss the requirements for placement of the fire alarm devices throughout the plans. Then we'll go through the fire alarm design in CAD to lay out the devices on the plans. And then we'll go into preparing the fire alarm riser diagram, as well as the sequence of operation matrix, which I'll explain what it is later in this video. So the first device I'm going to talk about with fire alarm systems are smoke detectors. Okay, and in section 907.2 of the New York City Building Code, they require the selective coverage smoke detectors. So a smoke detector looks something like this. You've probably seen it. According to this section, it's required in electrical rooms, IT rooms. So this is where you have data centers, these type of things, where it's just a IT room where you have servers and racks and that type of equipment. So every electrical room, every IT room, every transformer room, and a transformer is basically something that alters the voltage from one voltage to another. So this is just an electrical equipment, and whenever you have one of these, you have to put a smoke detector in that room. You also need it in telephone rooms or similar rooms. You need it in elevator machine rooms, elevator lobbies, top of elevator and stair shafts, above fire alarm panels, and heat detectors are to be installed in mechanical rooms and commercial kitchens. And this is required sometimes by the Fire Department of New York. It may also be required according to the local codes of your project. And that's because, commercial kitchens can create a false smoke alarm due to the smoke that can be present in kitchens. And also mechanical rooms can sometimes produce smoke, and that's the reason why heat detectors are sometimes required rather than smoke detectors, according to some local reviewing departments, such as the FDNY. All right, so I'm going to talk about duct smoke detectors now, which are basically similar except that they are on the duct. So here, let's talk a little bit more about this. So duct smoke detectors are required on return and supply ducts in HVAC systems with over 2,000 CFM, according to this code section. And CFM just stands for cubic feet per minute, and this is the unit that is used in airflow in HVAC systems, similar to the way that inches are used in distance and GPM is used in fluid flow, according to the units that are used in the US. So this is what a duct smoke detector looks like. If you look inside here, it's just a smoke detector within this kind of plastic container here with a nozzle that goes into the duct, as you can see here. And as the smoke goes across these openings in the nozzle, it'll end up in this container and where the smoke detector is, activating the smoke detector. And this is the way that it would look fully installed on the HVAC duct, which you see here in gray. So smoke detectors in rooms used as plenum return can serve as the return duct smoke detector. So where the smoke detector is required on the return, that requirement can be covered with a smoke detector that's actually just in the room if that room is used as a return plenum. So as you can see here, you can have an HVAC system such as this, and this is the supply. Okay, it's going here, and these are all the returns, as you can tell from the arrow. And the return goes back into the unit. So if the room is used as a return plenum, it just means that you don't have this return duct here. It's just going to be cut open into the room, and then the return opening on the unit is just going to be left exposed to the room itself, and then the room will be used as the return air path. So if you look down here, this is a typical indoor unit that you could see in larger buildings. And this is the return. So you could see the filter right here. And if this is left exposed in the room that it is in, that means that the room is used as the return air path, which means that a smoke detector in the room can serve as the duct smoke detector that would be required on the return duct. For return air risers, where the return air is greater than 15,000 CFM, smoke detectors to be installed at each story. And this meaning duct smoke detectors. So if you look at this diagram here, if this is the return air riser that goes to the HVAC unit somewhere above, and on each floor, first, second, and third, you have a return duct going into the riser. And if this system, this total return airflow is more than 15,000 CFM, you would need these duct smoke detectors at the connection point to each riser, basically right before it connects to the riser and the first inlet. The smoke detector has to be within those 2 points. Smoke detector activation shall shut off HVAC system serving that area. So whenever one of those smoke detectors, either on the supply or return side, is activated, then you would have to shut off the HVAC system. And that basically is to prevent further spread of the smoke throughout that space. So now we'll talk about remote alarms for duct smoke detectors. You have to provide remote light indicator in the ceiling for duct smoke detectors that are concealed above the ceiling. So they look like this. They will basically be on the ceiling, such as right here in this picture, if the duct smoke detector is concealed above the ceiling. And this is so that it's easy for somebody to see where the location of the duct smoke detector is that was activated. Now, if the duct smoke detector is exposed, then you would not need one of these remote alarms for the duct smoke detector. Now we'll talk about manual pull stations. In other words, they're called manual fire alarm boxes. Sometimes there are different names for the same thing. And they look like this, which you've probably seen before. And these are basically to be located not more than 5 feet from the entrance to each exit. Between manual pull stations, they are not to exceed 200 feet. And the height is not less than 42 inches and not more than 48 inches above finished floor to the handle itself. And the color of this has to be red because I believe that's easy to see if there's smoke. So they decided to make all of these pull stations color red. Next, we'll talk about strobe locations. And strobes are to be added to the following spaces. All bathrooms need at least one strobe. All rooms normally occupied by 2 or more people, such as conference rooms, staff rooms, kitchens, those type of areas. They are to be mounted so the strobe is 80 to 96 inches above finished floor. And strobes not to be more than 15 feet from end of a corridor and not more than 100 feet between strobes. Strobes should be placed so it is visible from anywhere in the room. So here is a diagram kind of indicating all of this that we just talked about. So the pull station, all right, is going to be max 5 feet from the exit door. This could be an exit door, right at the entrance to the building, or this can be an exit into a stairwell, a staircase, or it could just be not a door to stairs. The stairs could be exposed, and this pull station would have to be within 5 feet max from the stairs. The strobes, the entire lens right here of the strobe to be between 80 and 96 inches above finished floor. And the strobes here, which could be a part of a horn strobe, should be 15 feet max from the exit And here it's actually 15 feet from end of a corridor and not more than 100 feet between. But in this case, in this diagram, we show it to an exit door. So you have to make sure that it complies with generally both of those rules here. Strobe should be placed where it's visible from anywhere in the room. So this means that, let's say we have a room here. There's something here. Let's say it's a room, or it could be maybe just a wall. If you put a strobe here, the line of sight is like this. So people standing here will not be able to really see that strobe. So you would have to put another strobe in this location. Or you can get rid of these two and put a strobe here, and then this strobe will then be visible from anywhere within this room. So you have to make sure that the strobes are placed so that anywhere within the room you'll be able to see the strobe itself. And depending on where you put it, you can minimize the quantity of strobes. So this is something that should be considered when you lay out the system. So next we'll talk about horn locations. Horns to be added to the following spaces: corridors, conference rooms, open areas such as open office areas or warehouses. Usually the horns are combined with strobes in those areas, so then you would basically use a combination horn strobe. And they're generally placed above and near the pull stations at exit locations. So just like in this diagram again, the horns are basically combined into the strobe and placed where strobes are typically required. And you wouldn't put a horn in a bathroom just because a strobe is required in a bathroom. But they're generally located within, larger open areas, such as these listed right here. Next, we'll talk about CO detector locations. CO stands for carbon monoxide. CO detectors to be located per 2022 New York City Building Code, this section. And they are to be located in buildings that have a fire alarm system and contain these occupancy groups. CO detectors to have sounder bases, so these would actually start beeping at the actual device itself, which is not what smoke detectors do, but CO detectors need that sounder base within the device itself. CO detectors to be installed in these spaces here: any room with CO producing equipment, in corridors on the story where CO equipment is located, as well as one story above and below, in corridors on a story with enclosed parking or loading dock, as well as one story above and below. Activation of the CO shall shut down the source of that carbon monoxide. Next, we'll talk about water flow and tamper switches. So this is a water flow. Generally, fire alarm devices are color red, so that's one easy way to determine what's a water flow switch. And it basically goes into the sprinkler pipe. Water flow switch to be installed on sprinkler service and at each floor control valve assembly where fire alarm system is installed. So the service is basically where the sprinkler water pipe comes into the building from the street, city service. And this is an example of a floor control valve assembly. And this is generally required in high-rise buildings. So, where the distance from the lowest level, basically street level, to the floor level of the highest floor is more than 75 feet is considered a high-rise. And in that case, you basically need floor control valve assemblies to be able to shut off the sprinkler system serving that floor if you want to do maintenance without affecting all the other floors. So tamper switches to be installed on all valves controlling the sprinkler system where a fire alarm system is installed. So if a fire alarm system is not installed, the tamper switches, such as right here on the valves, can't go to fire alarm systems. You would actually put a lock and chain on the valves so nobody can actually shut it off. And for the water flow, if there is no fire alarm system, then this water flow switch will go to a bell on the exterior of the building. And if that bell is activated, there would be a sign there stating that the sprinkler system is activated and that somebody should call the fire department. So if you look at this floor control valve assembly, you'll see that this is the valve that shuts off the sprinkler service to that floor. This is the water flow switch. This is a drain, and you can see there's a ball valve, and when it's perpendicular to the pipe, it's closed. When it's parallel, so this turns 90 degrees, and if this handle is parallel to the pipe, it means that it's open, which will basically drain the system. So if somebody wanted to do some repair work on this floor, they would shut this off, open the valve, drain the system out, then they can modify the system, and then they would basically turn the system back on. This here is actual tamper switch, so it can actually come in this form here, or the tamper switch can be built into the valve itself. Right here, you see this yellow handle. This is a tamper switch, and this is where the wiring would be connected to the tamper switch from the fire alarm system. So this is what a tamper switch can also look like, not just this right here. So we'll now talk about lockable fuse disconnect switches and remote annunciators. So lockable fuse disconnect switch is to be connected before the main disconnect serving other loads for the building. You want to put it before, because if somebody shuts off the main service to the building, they'll be shutting off the power to the fire alarm system. To prevent that, you have to put it before the main disconnect. So this is what a fused disconnect looks like, and it has to be lockable so they could lock it and nobody can actually shut off power to the fire alarm system. The fused disconnect would provide power to the fire alarm panel. Remote annunciator to be located inside the building at the main entrance if fire alarm panel is not at the main entry location. So what this means is at the main entrance to a building, sometimes they want it to look clean, the lobby area. So they wouldn't want to put this big red box in the lobby right at the entrance. So what they would do is put this fire alarm panel somewhere in the cellar or the basement where it's not visible to the public. But then when the fire department comes to the building, the first thing they need to see is what the condition is at the building. So that's the purpose of this remote annunciator. It's very small. It will go to the entrance, the main entrance to the building. So once the FDNY comes, the fire department, they'll be able to see this immediately at the entrance to the building and see what the condition is. So on this remote annunciator, it will basically indicate, what has went into an alarm. It could be a smoke detector on the 5th floor. It could be a water flow switch on the 13th floor. So they'll be able to quickly identify what caused the alarm condition. All right, so we'll talk about control modules now. And control modules look like this. This basically goes into a standard electrical box. That's about 4 by 4 inches squared, about 2.5 inches in depth. So that's the approximate shape of these control modules. So these go on the SLC, which are the signal line circuit on an addressable system, and they're used as a relay for door release, magnetic lock releases, a CO equipment shutdown, or a fan shutdown as some things that these can be used for. So signal line circuit, just a reminder, is a circuit that contains the initiating devices such as the smoke detectors, the CO detectors, water flow, and tamper switches. So these control modules will go on that circuit and not the circuit for notification devices such as strobes and horn strobes. So the control module, basically, this will be the signal line circuit. So this will be the signal line circuit. It goes in here, and then it'll go to the next device. So the control module, if you look here, it has some relays here. So you have common, normally closed, normally open, and then you have another relay for a common and normally closed. So this is generally how it look like. So the normally closed, the symbol is like this, and the normally open looks like this. And normally means the normal condition when there is no activation of this control module. So in a standby case. So this can be used to have for fan shutdown. So I drew a diagram of a HVAC system here. So this could be the air conditioning unit. And within the air conditioning unit, it has a relay inside, and that relay is connected to the thermostat. And all of this thermostat wiring is low voltage, so it's 24 volt AC typically. And this 24 volt AC would sometimes come from the actual HVAC system, right? It has a transformer that will convert the high 120 volt AC or 208 volt AC to a low voltage 24 volt AC, which would feed the thermostat. So this is low voltage control wiring. And if the thermostat is calling for cooling, as an example, it would basically flip this 24 volt AC low voltage to a relay, which is within the unit. So it could be inside a condensing unit or a indoor fan unit. And it would basically just turn on the system. So when the current goes through this coil in the relay, it magnetizes this coil, which will flip this switch to close, basically sending the normal power to the HVAC system. Again, this could be a condensing unit or it could be a fan indoors. So this is generally the way that you control the HVAC system from the low voltage thermostat wiring. So if you're using this control module to shut off the HVAC system, for example, if a duct smoke detector goes off, you have to initiate fan shutdown for that unit. The way it works is sometimes they can take this thermostat power, run it through this normally closed relay right here, and then it basically will, in an alarm condition, this control module can be programmed from the panel. Since it has dials, it has an address that you can add to it. So let's say the address is 10. You can program the fire alarm panel to say when a specific smoke detector goes off that's related to this control module, to make control module with address 10, open up this relay, which will basically turn off the power to the thermostat. And when that happens, it'll basically shut off the HVAC system. And another requirement is that when you reset the system, so let's say the fire is gone, everything is cleared, you basically reset the system, turn it back on. That resetting of the fire alarm system is not supposed to automatically turn on the HVAC system, because I believe they're thinking that it could then maybe potentially spread smoke again, or maybe somebody could be working on the HVAC system and resetting the fire alarm control panel may turn the HVAC system back on, which could potentially hurt somebody that may be working on the system at that time. So the code requires a manual reset, and if you use the thermostat power to the control module, when you reset the control module and the power is restored back to the thermostat, somebody actually has to manually turn this thermostat back on in order to make the HV system run again. And this has just been something that I've noticed. Generally, I think that is the case for most thermostats. And that's one way you can comply with the code with that manual reset requirement. Another way these control modules can work is that these contacts are rated for a specific voltage and current, which are very low. And let's say you didn't have a thermostat type of system here where you could just run the low voltage through these contacts, which are rated for that low voltage and low current. And let's say you needed to run the higher voltage and higher current using this control module. The way you would do that is basically purchase a separate relay that can handle the low voltage, and you would run that low voltage through this. And through this control module, it would control that relay that would be field installed by the contractor to basically control the higher voltage equipment, such as kind of in this diagram right here. So this control module would be used to have door releases, for example, and door releases are where you use magnets to basically hold doors open. And if those doors are required to separate spaces into, fire areas, uh, in a in a fire condition, those doors have to close automatically to basically trap fire as well as smoke, depending on the purpose of that door. So these control modules can be used to automatically close those doors and also to open up doors. So that's what this magnetic lock release is. You need some sort of card to release the door because the door is locked by a magnet. In that case, if there's a fire, these doors have to unlock automatically so that the fire department could move around the building very easily without having to break open doors. So the control modules can also be used to control these magnetic lock releases to release those doors in a fire condition. Also, these could be used to shut off CO equipment. So any equipment that uses gas or oil or anything else that can produce carbon monoxide would have to be automatically shut off. And to do that, you can use these control modules as well to have the CO equipment shut down as well.